There's a thing. Okay, next again. These diagrams are headache. I'll draw the diagram. Okay, this what can you assume? There is some plain diagram at least. Using this, a student supposed to think. Okay, this is that liquid. Okay, now I think I have given enough help. So which cylinder is rotating? Outer cylinder is rotating. You can rotate inner also. And let me take the outer cylinder rotating. So if you want, you can change the problem. Let the inner cylinder rotate. Yeah. So what has to be done now? How to bring that? The liquid flow is laminar, taking into account that the friction force acting on unit area of cylinder surface of radius is defined by the formula. Okay, yes, given. We have to, no doubt, we have to derive it. So what shall we do? So again, we are going to take a layer which is at a distance r, small r, thickness of this be dr. Fine. So what is the area of? So shall I say we are going to consider a cylinder, not a ring. You're seeing the top view. This is a top view. Am I right? You are seeing the top view. If you see from the side, it will be like this, no? I think this will be top view. So now, so what we have to consider? So what is this? A cylinder of radius r, length l, and thickness dr. Now you see this. What is the surface area of this cylinder? 2 pi rl. What is the how the tangential velocity of this will be like this. Then how the viscous drag df. So let's define df. So what is the df is equal to eta into 2 pi rl into v. Velocity is v. At what distance it is? Shall we take it a distance r? Or how to write that equation? Anybody? Really, your engineering or circus, that thinking ability has to come into picture. So how to write equation? df, no? So what is the df force acting on that one? So if you look at actually, I have to. Yeah. No, the two layers you take it. Let me put here. So two layers you take it. One, this layer. So which will have more speed? which will have more speed? Outer layer will have more speed, no, than the inner layer. Will you look at those arrows? Tangential velocity. And what is the distance? R, and this will be dr. So what should be the net force acting on it? The difference of these two forces. The difference of these two forces. So therefore the dF should be equal to eta 2 pi RL dV by dr. I should take it. So what is dV? V equal to R omega. So dV should be V equal to, in fact, here R omega. So this should be equal to dV by dr. So eta 2 pi RL. dV is what? R d omega by dr. This is a condition. Because what is the difference in the velocity between them will be dV. If this is at a distance r, what about this one? This will be at a distance r plus dr. So the difference in force, the equation will end up like this here. So what is the basic reason? V equal to R omega. This is a primary equation. Once you get this rest all, you can manage. So therefore this will become equal to 2 pi eta L R square d omega by dr. Now let's go for torque. Torque acting on this. D tau equal to df into R. 2 pi eta L okay, this torque, okay, I'll go for integration. Now in the integration, what we have to put it again, the same mathematics we have to bring it. dr by r cube equal to 2 pi eta L d tau, or if you want, you write it d, this one. Again, d tau will get confused. So this should be equal to d omega. Anybody limit? Can you suggest limit? At a distance r1, what is the velocity? Angular velocity should be 0. At a distance r, let omega be the angular velocity. This is the one equation. Then again, okay, no. What should be the limit? At a distance R1, because the inner cylinder is fixed, no? So therefore it is at velocity. Outer cylinder is rotating with angular velocity omega. What was given? Constant angular velocity omega 2. Yeah. Okay, right now, solve this too. Solve this, you'll get expression for the angular velocity. Option B, the moment of friction force acting on a unit length of the outer cylinder is asking torque per unit length. After getting this, come back and substitute here. You'll get an equation. I think let me solve it. Dividing these two. This will become log of, not log, this will be minus uh, 2r square, no? Let me integrate that. I think it is. This will become minus 3 plus 1. So minus 2r square r1 by r r2, this should be equal to 2 pi eta. This will get cancelled out. Omega by omega and omega 2. Okay, solving this. Minus 1 by 2, minus 1 by 2 get cancelled. So the limit will be 1 by r square minus 1 by r1 square. 1 by r square, 1 by r2 square minus 1 by r1 square. I'll write, so the final equation will be omega 2 r1 r2 whole square check it once. This will be your answer. Small r, it should be smaller. This will be the angular velocity of a layer at a distance smaller.